Yeah. Hello to everyone who's been here before at like a Predibase webinar or has seen me at one of the webinars. But for those who haven't seen me before, I'm Arnav. I'm one of the machine learning engineers at Predibase. Been here for about a year, and I work a lot on large language models, as well as distributed training, and sort of scaling our ML infrastructure where needed for different like training jobs. And I also work on our open source side on Ludwig, which is sort of the open source project that Predibase sits on top of, that you should check out. Prior to being a Predibase, I was at Atlassian, where I was training a lot of machine learning recommender systems for different products like Confluence and Trello, sort of helping build and doing a lot of work in like social network analysis and graph networks.
Great, thanks for the introduction. All right, let's get started. So we're gonna talk about 10 things LLM, but let's start with what exactly are LLMs to give us a good foundation.
Okay, sorry, I think my Wi-Fi might have disconnected. Am I back?
No worries, yeah, you're back.
Okay, yeah, sorry. So maybe we can just continue from, I think you were saying like the first question that
I
you
was
had for me.
gonna say, let's just give us the foundation. What is large language models? And whenever you're ready, do you want to, if you have any slides, feel free to share.
Yeah, absolutely. So I think, the best way to sort of think about large language models is to understand language as we understand it as humans, and sort of like how that motivates doing language modeling through machine learning, and then how that takes us to large language models. So, as humans, when we read, we sort of perceive text as this like collection of words. And the reason we're able to make sense of it is because the words show up in a sequence or like a sort of a structured ordering. And the ordering is based on grammar. Now, what's really interesting is that for computers, text is just a sequence of characters. And as they say in like a cliche way, it's just bits or bytes. And language models, just at their core, are machine learning models that are aimed towards enabling machines to comprehend like text in a similar fashion to humans. And language models by themselves have existed for a long, long time, since the 50s. They were very simple rule-based systems that follow grammar and natural language. But then over the years, as there's been much more collection of data and advancement in statistical techniques, we've dived into more data-based learning as opposed to rule-based learning. And so language models have existed even in 2017 and before. But what's unique about large language models is that they're based on something called the transformer model architecture that Google Brain came out with in 2017. And large language models are specifically trained on a massive scale using this transformer architecture, both in terms of like the data, so the amount of data that they're trained on, and the size of these models. And the technique that's sort of underlying all of this is deep learning. And it helps, and the model is essentially learning how to generate human-like text based on this training data. And so the way these models work at some core level is that they take this input string of text, and then they process one word or character at a time, and then produce a character or a word as output. What's made LLMs, I think, I know the question was like, what are LLMs? But I think what makes them so interesting and why we're here is that because we train them on so much data and at such a big scale in terms of the model size of the model, we've learned that they actually develop something called emergent properties, which are essentially these like abilities that are not present in like more traditional smaller scale large like language models. So even without training them specifically for these tasks, they can do things like arithmetic, question answering, summarizing passages, and much, much more. And that's pretty cool, because that means that we all like through large language models, we're able to do a lot of things that we weren't able to do before in a very like short amount of time.
Great. So in the next few questions, we'll talk more about how do we train an LLM? And then, yeah. So today we hear a lot about large language model. There's a new model out there each day. So how can we put it into use? What kind of business problem can we solve with it?
Yeah, great question. So I think, like you said, there's been a big explosion of LLMs in the last year, and increasingly much larger adoption in the enterprise space. Everyone is thinking about their AI strategy, and it comes largely from the fact that LLMs have unlocked these new capabilities. And the way most of us have interacted with it today is through ChatGPT, where we ask questions and we get responses. But chat is actually just one of many ways to extract value from this new technology. I think there's actually many use cases that we can put in production today in the span of a few days, such as text classification, extracting information from unstructured text, creating new content, or product descriptions, actually generating structured data. So imagine going from natural language to JSON or YAML, which is really useful for developers in particular. And then, as we've already seen, sort of question answering, but expanding that to search over hundreds of documents. And so a lot of these sort of applications are already sort of gaining traction in the enterprise space, way beyond just using chat. And there's so much more that people are coming up with every single day.
Gotcha. So now let's talk about how do we train an LLM? Should we, for example, should I train them from scratch, or what's the best way to train a model?
Yeah, that's a really good question. I will actually share my screen here, because I think there's probably like a fairly good way to follow like the high level overview of how these LLMs are trained. Those who are familiar with machine learning will find this a lot easier to follow, or those who have already trained a text model before. But if you haven't, hopefully this will still capture the essence of what happens. So essentially we get training data, which is a large collection of text. It could be books, research articles, websites, and things like that sort of get collected together in a set. And then the thing about machine learning models is that they can't take text directly as inputs during training. So we need to represent text in a numeric form. Every model has this notion of a vocabulary, which comes from a process called tokenization. So at a very simple level, imagine assigning each letter in the English vocabulary a unique number, and then converting your text into those numbers. Once we're in number form, that process is called tokenization, and those numbers and so those numbers can be fed into your machine learning model for training. So yeah. And then the next thing that we usually do, and why LLMs became really big, are these, you need to pick an architecture. Some of you might be familiar with GPT-2, GPT-3, GPT 3.5 that OpenAI sort of pioneered and sort of has been building on for a while. But there's also others like Llama that Facebook came out with, and then GPT-J, GPT-Neo, Falcon, which is a new big thing, and many others. So you need to pick sort of like a model architecture that you feel like you want to train with. So given this tokenized data and a model architecture, we can actually start training a model. What's really cool about sort of these kind of text models is that we don't need to have a labeled data set. And that's that's a very important point, because essentially what these models are learning is given a set of input just to predict the next token. And then it can just keep doing that. So you can create these pairs of inputs and outputs by just predicting the next word. And so that's basically the training process in a nutshell. Now, let's say you have a trained model. You actually want to use it in a productive way. Usually we do that through prompting and generation. Think of your ChatGPT interface that you've seen before, or those of you who like to play around with open source models, the same interface where you can provide a query and you get a response. And the responses that you get are usually based on the sort of like the learned knowledge during training. So it's the grammar, it's the sort of like words the topics that it was trained on, and that's what it's able to answer with. And then finally, so that's usually pretty good for most cases. Now, let's say you actually want to go beyond general intelligence. So when I may say general intelligence, I mean, it's nice to actually, create a poem or something of that sort, but you actually want to use it for a production use case. A lot of the times you want to tune the weights further for your specific task. And then we go into a process called fine tuning. So you can continue training on some very specific data and then cater your model towards that specific task.
Great. So I know in traditional machine learning, processing data, cleaning data is always taking a lot of time of data scientists. So with large language models, we can, the data can be a little bit unstructured, and the model is still able to extract useful information from it. So that's one of the things that's make it so powerful. So you mentioned model training and fine tuning. So there are a lot of open source model out there, and also people are using the APIs from OpenAI. So how do you compare those two?
Yeah, that's a great question. So I again have slides for these. But so at a very large level, you have these two choices as an enterprise company. You can either go the closed source model way, which comes from companies like OpenAI, Anthropic, Cohere, or you could go the open source way. So, and there's a lot of companies sort of building in the open source. One of the reasons closed source or OpenAI got so popular is because, as you've seen, the quality of responses is usually very, very good. They have large context windows, which basically just means that they can take in a really big questions and still produce a response. They manage infrastructure for you, they're very good for proof of concept. So all it takes to build an LLM app today is getting an OpenAI API key, saying, making a call through their API or SDK with your question and then getting a response, which is really fast. So, they take all the hassle of managing infrastructure and things of that sort. Right. And so it seems like, and that's why, all these companies have very popular offerings out there that you can use. However, that's a good start, but there are some fundamental limitations that you must consider as an enterprise company. And I think this is important. One, these models are hosted by third party, right? So there are some potential data privacy concerns in the way they're managing the data that's coming in as queries or the data leaving. Right. The second is that, as we discussed, a lot of the times you want task-specific models as opposed to general models, because those are more useful in production. But a lot of these companies have fairly poor customization offerings, so you can't really fine-tune, or if you can, it's pretty tedious to do it. So it's a bit of a barrier to entry there. You're obviously potentially locked in with this vendor because now you're aligned and you've integrated all of their APIs into your workflow. We also don't actually know how they're training their models or what model architecture is being used. And I think, like, as someone who's worked in the machine learning space, I think it's really important to have that sort of like transparency, so you feel more confident in what's happening, right? And then finally, I think the things I've heard the most from a lot of people I've talked to is that you're often rate limited. So if you make a lot of requests, right, you're limited by these service level agreements where you can't make more requests in a given amount of time, which might be pretty disruptive to your sort of enterprise workflow for an app that you're building using LLMs. And also, it's actually pretty expensive to scale. Like, I've heard of, almost up to, like, GPT-4 can cost almost like $10 to $15 per 100 queries, which is not cheap by any means at all. And so, yeah, they're definitely pretty expensive. So that's sort of like the high level overview of how I see closed source LLMs. Great to start with, very powerful, very good. But I think as an enterprise company, there's definitely a lot of things to think about. On the other hand, there's been a lot of innovation in the open source space, where in the span of about 3 weeks, we went from an open source version of Llama 13 billion to Alpaca 13 billion, which by some evaluation metrics was about 98% or 92% as good as ChatGPT was at the time, right? And so open source large language models are actually catching up really quickly in terms of both performance, quality, and also there's a lot of innovation in the space. A lot of cool things that we'll talk about hopefully later, like LoRa, were actually sort of open source contributions and innovations that bigger companies have then gone back and started to use. And so there's a lot of promise in open source LLMs, and their quality is quite good. Definitely a little poorer than closed source large language models, but that's not to say they're not very close. But again, not everything is always golden. There's also, some, difficulties. One moment. Yeah, there's definitely like some difficult, like the positive aspects beyond just quality and things that we already talked about. You can make them fully customizable because you have all the weights. Continuously improved by the open source community. You are managing your own compute, so that means you don't pay per token generated, but just the cost of hosting the model, and you're not rate limited. And then since you host it yourself, you sort of ensure data privacy, which is good. But again, it's not always easy to host and do and use LLMs. Hosting these models, training them, making them really fast for inference and querying means you have to manage all of your own infrastructure and make it really easy to sort of access these like capabilities that large language models expose, and requires highly specialized infrastructure. There are many companies just like Predibase, sort of innovating in the open source LLM space. And Predibase actually offers sort of all of this stuff out of the box. So it's really easy to maximize value from open source models and almost treat them like you're using closed source models in terms of the way you interact with them. So it solves all sorts of like the limitations and challenges that come with open source LLMs. As a personal viewpoint, I would say I think open source LLMs are the way to go. Just more transparency, more innovation, and just more control of what you can do with them compared to the closed source offerings.
Yeah, that makes sense. And also, because we mentioned a little bit of fine tuning, and then I think someone asked a really good question: do you lose the knowledge, the capacity that's trained through the original model when you do fine tuning? I think we can maybe answer the question later when we talk about fine tuning. Previously, you mentioned a little bit about, prompt. So what does it mean to prompt a model, and what exactly is prompt engineering?
Yeah, great question. So essentially, all of you have anyone who's played with ChatGPT is sort of familiar with the notion of prompting. But if I was to sort of like formalize an explanation, it's sort of like the mechanism with which you interact with large language models. So it's sort of and what that really is it's just the input that you give it. Usually it's like a question or a statement or a description of a task that you want the LLM to perform. And then you might accompany it with some additional contextual information for your task to give you like what that might look like. This is a pretty typical structure of what like a prompt might look like if you were to prompt for a task. Usually have a task description which says, in this case, answer the question based on the context below. Keep the answer short and concise. Respond unsure about answer if you're not sure about the answer. So sort of like some high-level rules about what the model should and shouldn't do, as well as what you want it to do. You give it some contextual information. In this case, the reason we give it this context is because we're doing a question answer. We're asking it, given this context, what was OKD3 originally sourced from? This is just like a pharmaceutical passage I found online on some news article. But the idea is that you can structure prompts in this way beyond just asking it simple things like, what is 2 + 2, or can you write like a poem for me? Like you can get very creative with your prompts. And so to answer your second question, which I think was sort of, okay, we have this prompt and we can get these responses back from an LLM. What is prompt engineering? So the way I can describe that best is essentially, as the name suggests, it's the process of like you sort of design a prompt and then you refine it iteratively. And the goal is to essentially improve the quality of the responses you're getting back and the specificity of the responses generated. Right. So essentially the goal is you're trying to craft these prompts to guide these large language models that have all of this information sort of learned during pre-training towards the desired output that you want, and then minimize the undesired behaviors or biases that it might have. So you get just basically the response that you want. And sort of experimenting in this fashion helps you extract a lot more value from your large language model than just asking one prompt and calling it a day. And I thought what might be interesting is that there's to share is that like here are some examples like of prompts as well. As I was saying before, you can use for many different tasks. There's like text classification, but you can also mold it to do information extraction, text summarization, question answering, search, and so on. Um, and oh, um, and some common ways of sort of like prompt engineering to get to a good prompt from an initial prompt are like these 5 dimensions I like to think about. So there's this notion of instructionality, which is essentially be as clear and concise with what you want the model to do. So if you're doing text summarization and you say, summarize this paragraph above or this context above into two sentences, or list exactly 3 advantages of renewable energy, then there's context setting, essentially giving the model enough information to be able to answer the task at hand that you're asking it to do. Oftentimes what you'll see if you guys have played around with LLMs, including ChatGPT, is that it will tell you it doesn't have enough information. That's usually a sign that you need to give it something more. But context setting is really, really critical. One thing that we've found sort of experimentally is that system messages are also very interesting. So if you say that you are a smart AI assistant in like a financial bank as like sort of like a system message, it basically tends the LLMs tend to like sort of take on that role and sort of respond. There's a couple of cool things about it that gives them more context on the types of responses to give, sort of the domain of the responses to give, and sort of what the expected output is. And it's been found empirically that LLMs tend to steer towards better responses if you use these kind of system messages. I believe even ChatGPT, there was like a leaked article somewhere that showed like sort of its system message that like Microsoft uses or OpenAI uses, and has something similar. User demonstrations are another big part, where essentially sometimes you want the model to do something based on your prompt, but it may not know how to do it because it didn't see it during training or does not understand that. And so giving it some examples of what you want it to do as part of the prompt also goes a long way. And we'll also talk about this a little later in like the form of in-context learning, but user demonstration go a long way. And then finally, constraining the models, telling it what it should and shouldn't do also goes a long way. So you're allowed to say this, don't say this. Or if you saw my previous slide where I said, say you're unsure when you don't know the response is a constraint in itself. And so doing some combination and iteration over these 5 attributes typically will get you very, very far in your prompt engineering story and help you extract maximal sort of value from your prompts.
Yeah, I really like those 5 kind of best practices. Could you go back to the previous slides and then the previous one when you prompt?
This one or the one before this?
And another one.
This one?
The one, yeah. So when we talk about prompt, this is basically how you structure it: task, context, and query. So this entire block is prompt. Correct?
Yeah.
So and if you go to the next slide,
yeah, one moment. Mm-hmm. Able to see it?
I was able to see it. So for example, below is the context. Okay.
I can.
Yeah. So basically, I just kind of, maybe you can give us some example on the best practices you mentioned. For example, you said there's a some part you give on constraint. I guess maybe we didn't tell them, hey, you're expert in those examples.
Yeah, absolutely. So the only reason I didn't put that in is because I had only a little bit of space on these slides. But if I was to structure these prompts, what I would do is, let's say we take let's take the information extraction use case. So essentially what that paragraph is about is just saying that people who are now writing paper using ChatGPT should credit ChatGPT and make sure they point out where. And the idea of the information extraction is, given this paragraph, can you tell me what large language model is used in the paragraph? So this is just some context on what this prompt was. And if I had to add, let's say, like a system level, some constraints, it would be, if you don't know what the answer is or can't find it, say you can't find the answer. And then maybe another thing you can do, which we'll talk about later, is say explain how you arrived to the answer. So that can also be something you can add to the prompt. You can also say you are essentially like, let's think about it. An assistant that acts like a search engine or something of that sort, as like a system level message for like information extraction. And then some of the other things we talked about were being specific. So I thought like the example I gave of like mention the large language model based product like is very, very specific on like what I want the output. So that's how that's used here. But this is just, these are relatively simple, unfinished prompts. But ideally, you want to have some of all of the things. The one thing I will say, there is a bit of a trade-off as well, which is that as you add more context, the amount of sort of like context you can get back from the model through generation reduces. All these models have this notion of like context length, which is the total number of tokens that it can take in and then produce as output. So the more you sort of pass in, the fewer sort of can be generated. But that being said, I think in most cases it's usually fine, and it's like the better thing to do to get like very deterministic, high quality, favorable responses.
Yeah, I don't know if this makes sense. Maybe we can start with like a shorter prompt, so you can provide maybe more answers, and then if you feel it's too wide, it's not very specific, you can, you know, add more context to your prompt and then narrow the scope.
Yeah. One thing I tried recently that I thought was pretty fun was actually asking the LLM to help me improve my prompt. And so the way I did that was I started with like a one-line description of the task. And I said, initially, I'm going to give you a prompt. And what I want you to tell me is some alternative phrasings of the same prompt, as well as what information you're missing that you would like for me to provide for you to do better on this. So through like a few cycles of doing that, essentially I got better and better prompts, like more complete prompts with all the context the LLM needed. And I found that it performed like a whole lot better than me iterating on it. So there's some automated smart ways you can do prompt engineering, but I also think it's really nice to go through the exercise you described of start with like a very simple prompt and then slowly add these pieces and see the effect that they have on the output.
Yeah. Great. So we talked about best practices around prompt engineering. So I think a lot of people ask us, what is zero-shot learning, few shots learning? I think those are the kind of terms we talk a lot about these days. So what do those mean? And also, do I need any data to get started with LLMs?
Yeah, great question. So some of these terms like zero-shot learning, few-shot learning, or in-context retrieval, retrieval augmented generation. There's a lot of like fancy terms being thrown around for relatively simple ideas. I think the sort of like the high-level idea of what these terms are talking about is this idea of the degree of customization you want to provide to your LLM. So as we discussed already, we don't really like a lot of these models that are trained on a large corpus of data, sort of know about all of these topics, but they're very general. But to actually use them in a way that's useful and productive, you want them to be hyper specific and very task oriented. And so zero shot, few shot, fine tuning, all of these are basically degrees of customization that you can sort of provide or use to orient your model towards your task. So the easiest one to start with is zero-shot learning. All a shot really is an example. So providing we talked about user demonstrations, I think, in sort of prompt engineering best practices, and there's a sort of an extension of that idea where in zero-shot learning or zero-shot retrieval, you just specify the task with the choices, but you don't actually give it any example. So it's the easiest thing you can sort of do out of the box. And all that's happening is that the model is using all of its learned knowledge from training to answer those questions. So in a lot of cases, what you'll find is, and the best part about zero shot, or this notion of customization with no data, is that it's purely based on the prompt. You don't have to provide any examples, and you actually need zero data to get started. So you can already extract maximal value. For example, or not maximal value, but like a good amount of value. So an example of what this really means, just to like sort of ground this a bit more, is say you have a text, like actually like on this slide, we see this text classification example here, where we say, classify the text into neutral, negative, or positive. And I give it this text saying, I think the food was okay. And I ask for the sentiment. The cool thing about this is that I didn't have to train a machine learning model on any data to get a response back from the model. And what you'll find is if you actually take something like this and pass it into a reasonable sized or reasonably good LLM, it will actually respond back with neutral. And so that means without any data, using zero-shot learning, which means don't have to provide any examples, I'm able to do things like text classification purely based on the knowledge that the model learned during training, which is quite neat. But what we can do is also sort of extend this idea to few-shot learning, right? And what few-shot learning, like I said, shots are essentially examples. So it's embedding examples of the task, sort of the input and output response pairs, into the context of the prompt. So maybe let me see if I have an example of that. Maybe I do. Right. So this is an example. So for example, let's take the same text classification task that we just did. What we can do is actually give the model some more context. So here I'm giving examples of a positive review, a neutral review, and a negative review. And the reason, like what's been really interesting is that the way these models work is they go from, like in English, sort of like from the first word to the last word. And so as they're sort of processing the text, they learn sort of like the, if you will, like when they read this context, they sort of get more ideas about like the topics and the sort of like context or domain space for this prompt. And that actually assists them a lot when you ask them the question. So what's cool about in-context learning in particular is that, you know, you can actually have the model do well on, let's say, say the same, imagine the same text classification task, but you're like at a company and you're signing like, you know, customer requests to different departments, and each department has its own like special letters or abbreviation. By default, the model actually won't know like what like some of those might be, right? But if you give it examples of, okay, when this comes in, send it like the output class should be this, and when this comes in, the output class should be this, as well as a description of those classes, you can actually just solve like a text classification task for your custom classes that it's never seen before, all through this. Now, I've been talking about text classification because it's a really easy example to explain this notion of in-context learning or few-shot learning, right? But this can actually be expanded to pretty much like anything. And we can take this idea of augmenting the prompt with the context to like a sort of like second level. And what that is this notion of retrieval augmented generation or indexing. Some people call it RAG. And what it means is that imagine I have this data, right? I have these examples of input-output pairs. But like I said, one of the limitations of LLMs is the context window, which is the amount of information you can pass into the prompt. So you can't, in an ideal world, you take your all the examples that you have, put in the prompt, send it to the model. But that's not always possible because of this context window. So what you want to do is actually maybe select the most relevant examples, add them to your prompt, and then you know, make a query. So we can actually go you know, way beyond just text classification, do a lot of cool things like answering questions over your data set, right? Like maybe you want to know, you know, you have your like Expedia and you have a bunch of hotels and you want people to find out like, you know, people are curious about what hotels to avoid or what areas to avoid. And you have all of these like reviews that people have left on hotels. You can essentially use build question answering or search using this notion. So I thought to build this like architecture diagram to explain how it works. It's very similar to what was happening before, but a bit more automated in the way that it works. So let's start with the query. Imagine my query is something like, what are the hotels with the poorest reviews in San Francisco? So let's say that's the input query. Behind the scenes, I'd say I have a data set with all the like hotel names and like different reviews from different people, right? So what we can do is let's call that external data. We will chunk it. Chunking is essentially, all it means is taking large pieces of text and breaking them down into smaller sub blocks that can be sort of ingested or ingested. The reason we want to do that is, again, if the blocks are too big, we can't fit them into the prompt. So we want to take the big document, break into small sizable chunks that we can fit into the prompt. And then we do something called indexing. A lot of you might be familiar with vector DBs, or and the tools like that, like Pinecone or Milvus, or other tools like that, which are some of which are open source. And essentially, like, that's where they fit into this like story of LLMs, where you take these chunks of data, you embed them. So you have a special model called, it could be any model really, but it takes text as input and produces something called an embedding. And these embeddings are essentially like a model's internal representation of the text. But what this representation actually stores is semantic information. And so for each chunk, we can store this semantic information and store it in this vector DB or vector index. There's many tools, like I said, for doing this. And we do this like sort of in advance of a query. But now let's say when I ask a query, what I can do is I can take the query, embed it using the same model. So I get like sort of like a contextual representation of the query, and then see what the closest semantic matches are in my data set. Pull out like the top, let's say 5 most similar. So you can imagine if I ask my query as, what are some of the hotels with the poorest ratings in San Francisco? Some of the reviews that have San Francisco mentioned would probably show up as contextually similar. Some that have like just poor rating by sentiment will also be candidates. But we want ones that have sort of both together, right? And that's what this embedding retrieval system will do based on semantic similarity, and return sort of like the 5 chunks or 5 reviews, if you will, that have most similar, and then put those as context into your prompt. So you've taken your query, you've grabbed five of the most semantically similar examples, you put them into your prompt, and you say, here's some context, and then you ask your query, which is, what are the hotels with the worst, poorest ratings? And it uses that context information with the hotel names and things to answer the question. And so that's how you can get a response. You can do this for text classification. You can do this for question answering. You can do this for information extraction. You can do it for all of the tasks that we've talked about so far. But it's really powerful because you're picking your examples very smartly, and you're also able to manage within sort of like the context window constraints that LLMs have.
Gotcha. So in the context of prompt engineering, we can think of zero-shot training as, without any context, you just ask, hey, can you tell me what recommend a good movie for me? And then few shot would be, hey, this is a few movies I like, I think those are good, and this is the movie I think is bad. Now can you recommend a movie for me? So do you think this is a good, so like the relationship between kind of prompt engineering and zero shot, few shots, can you kind of help us align what's the relationship there?
Yeah. So your examples are absolutely correct. In the first case, you sort of just ask, but you don't give it much context. You can give it some, but you're not using. So the biggest thing with this like idea of short is that you're telling the model, giving it examples of how to solve the same task. There's like other examples of, here was the task, here was the response.
It's like give you a little bit of kind of supervised learning.
Exactly. It's exactly giving it like some supervised learning context through like very few examples. So yeah, in the first case, you don't have to give that, and that's basically just using whatever it's learned. But in the second case, it's using its learned knowledge from training as well as your context to figure out how to respond better. And so in your case, yeah, absolutely. Like it would give a much better response in the few shot case as opposed to the general case with zero shot learning. The way this bridges together is that, like we discussed, there's 5 things with like good prompt engineering to kind of get to a good prompt. So this like idea of zero shot or few shot falls in one of the categories called user demonstration, which is telling the model how, like, examples of how to do the task, because it may not know how to do it. And then once it starts if you give it enough examples, it will learn how to do the task most likely without training. And so that's where the gap is bridged. I think providing context is always important, no matter what the task. There's a difference here is that the context we're providing is telling the model how to solve that task, because by giving it examples of how the task has been solved in other instances. So yeah, context can go in many ways. This is just a specific type of context that generally does very, very well for tasks that are not very easy to
Yeah,
do.
gotcha. Yeah. And I think previously we gave a demo on unstructured data. So there's a lot of use case around retrieve information from unstructured data. Could be a PDF document or maybe some type of query. So how can I use my data with LLMs?
Yeah, so this is actually like the exact example of that. That when you have, let's say you have unstructured or structured data, the main idea of like using it is, I think the best way to use it is through the retrieval augmented generation. This exact slide, where you're able to use the actually extract the most important data and use it in your prompt to sort of help answer or do certain tasks. So let's do like both the cases. So in the case that you have unstructured data, which is PDF documents, Word documents, things of that nature, I think this chunking idea is very, very useful there in particular, because what you can do is you can extract these, like, think of it as like, let's say you take each chunk as a paragraph in the document, you can embed it and then use that to answer questions or use about your data, about your own data, or use that to answer other questions. Like for example, given example, so like we talked about, there's given example XYZ, like can you, sorry, let me take a step back. So given some context, can you help me answer the question using that data itself, like the movie hotel reviews example that I gave you? Or it could be, here's some examples that have happened in the past. I want to try and figure out what will happen in this hypothetical scenario. What do you think? And so that's like the text classification case. But in either case, you're using your data just in very different ways, right? And so all of it comes down to like the type of data you have. But I think the fastest way to use your data is through prompting, specifically in this few-shot retrieval augmented generation style. And usually what we've seen is that retrieval augmented generation, sort of the semantic-based picking of context into your prompt, does a whole lot better than randomly picking examples or chunks from your data and putting it into the prompt. So yeah, that would be like my recommended way. But the other part that this leads into naturally is fine tuning. Do you think that's like a good point to talk about that?
Yeah.
Okay. So there's this like other sort of notion, which is fine tuning. Actually, you know what? I think So there's this other notion of fine tuning where you're essentially, so far we haven't actually played around with the model's parameters itself. We're using what was already trained, but we're trying to use it for our specific tasks. Often what happens though is that even with a lot of good prompt engineering practices, a lot of iterations, the model tends to do things, either it's not able to solve our task, or it behaves in ways that we don't want it to behave, like it gives you answers that you would never want to give, things of that nature. And I think that's a good point where you say that, okay, I think maybe I need to actually customize the model even further to my data, using my data. And in this case, we'll specifically update the weights of the model. So before we dive in, I think like the three places where few-shot learning sort of excels is when you have a limited amount of data, let's say like in the order of like hundreds of examples. I think like that's a great point to use it, and usually it will do pretty well with prompting. It's where sort of, you want to quickly test an idea and adapt your data to a task, right? So again, there few-shot learning, retrieval augmented generation, all very, very useful. And the third is, let's say you have data, but it's hard to acquire more data. Again, in that case, this is really good because things like fine tuning usually require like a lot more data and it has to be really high quality data. But if you have both of those, then it performs better. So you can typically get like 90% of the way just through prompting and prompt engineering. But the last 10%, I would say, is like through fine tuning of sorts. What might be useful, I do have some slides on fine tuning. But for those who are not familiar, what's different, the difference between like prompting, where we were just asking questions, and fine tuning is that in fine tuning, we're actually going to go into the training process of the model and sort of work at that level. We're going to update the weights of the model based on certain tasks and like sort of teach it our task. So imagine, for example, you want to do structured data generation. You want to generate like YAML or JSON files, for some, maybe you're building like an API layer and you want like the API responses to come from the LLM and just plug those in. Then in that case, it's possible prompting doesn't get you very far. But if you take a data set and you fine tune, let's say LLM, you can actually, you'll find that the model tends to perform better. So that's the general like idea behind fine tuning and what like the process is itself. And there's many different ways to fine tune. So hopefully this is, for those who are familiar, this should be a lot easier to digest, but I'll try and keep it like very simple. There's three sort of notions. There's, you either update the entire model itself. So usually LLMs come with an encoder, which takes text and represents it in some sort of numeric form. And then there's a decoder, which takes this numeric form and converts it back to text, essentially. So you can update both of those parts and all the weights there. It's usually pretty expensive to do, but it might give you the best results. I know there was a question earlier that you mentioned where someone said, if you fine tune, will it forget all the knowledge it has learned? Usually in the case of full fine tuning, it's very common that it forgets all of what it's learned. And it's called catastrophic forgetting. So it's usually, like, in my opinion, not a preferred way to go. But yeah, do you update the pre-trained LLM encoder and the LLM decoder? Then there's like, oh, let's just train an encoder and train a separate decoder. So the easiest way to think about this is, in the old sense of the world, before pre-LLMs, you would have BERT, and you take the pre-trained BERT model, you would make the weights trainable, and then you'd add on one or two layers for your task. So imagine you want to do text classification. You would take the BERT encoder, unfreeze the weights, add two fully connected layers, and then get an output. For those who are not familiar with deep learning and this notion of layers, essentially, it's basically just teaching it some additional parameters for your task, while keeping some of the weights the same. The third is freeze the encoder, train the decoder, where you just use pre-trained BERT and you just tweak like 2 layers or 3 layers that you add on. So all of these 3 strategies sort of exist for fine tuning. All have different complexities, different advantages and disadvantages. But what we found empirically, and I want to come back to like the answer of like the catastrophic forgetting in a moment, it'll all wind back up, is that LLMs are huge. Like, ChatGPT is 175 billion parameters. I read an article recently saying GPT-4 is 1,610 billion parameter model. So it's like actually in the trillion parameter range if you put all of those models together. Updating all of those weights there's actually like, it's very, very difficult. The reason is that, it's expensive, both in terms of time, in terms of compute resources, which are hard to get by, and the compute itself is very, very expensive. It tends to lead to worse performance when you update all the weights. And then the biggest disadvantage is that, let's say you have task A that you want to solve through an LLM and task B that you want to solve through an LLM. You will actually have to fine tune all the weights for each of those and essentially have 2 separate LLMs, like one for each task, which is actually very expensive because both training is expensive, but then actually using it in production for inference is also very expensive. And so what we found is that, not when I say we, sort of like the open source community and others, is that there's a notion of parameter efficiency.
I think it's frozen on our side. Let me ping him really quick. Maybe we can answer some questions here. What are some questions you can type in? We're gonna do a Q&A really soon, and let us know if you have any questions. Hey, you're back.
Okay, yeah, sorry, my Wi-Fi has been a little spotty this morning. Let me go back to where I was. But essentially, yeah, there's just to catch everyone up once again where I left off. Instead of full fine tuning, there's actually an alternative called parameter efficient fine tuning where you don't even update the weights and you just add in these like layers in between the LLM that are trainable. So it's like significantly fewer parameters that you train. And you can train an adapter or sort of these like, I'm calling it adapter. That's like the sort of like terminology, but these sort of like mini modules for each task. So you can keep one LLM and then have many small models for each task that are based on the same LLM, which is really nice, both in terms of cost, resourcing, training, sort of all the benefits, or the opposite of all the sort of difficulties that you'd face with full weight fine tuning. And there's many sort of like methods for parameter efficient fine tuning. It's popular even in computer vision, but I think the ones that I want to talk about today are specifically like LoRa, which is very popular. For some context on why I think it will be interesting to discuss, Llama was released by Meta in I think Feb or March last year, and it was a general sort of model. But some researchers at Stanford essentially came up with a data set called the Alpaca data set, and they fine-tuned the Llama model using these LoRa adapters or modules on that data set. And it was very cheap for them to do. I think it costed them like $500 or fewer. But what they got at the end of it is basically a model that was very close to, like, I think it was like 70 or 75% as good as ChatGPT. And it only took 50,000 rows of data to fine tune. And the advantage is that, for someone's question on like the catastrophic forgetting, is that because we're never unfreezing the weights of the LLM, just adding in new weights in between, the advantage is that you don't lose the knowledge that it already has. You're only adding more task-specific knowledge into its domain. And I like LoRa in particular is very interesting because it was sort of groundbreaking in that it was very effective, able to achieve very similar performance to potentially full fine tuning or on large amount of data with all the correct steps. But really, like for those curious, it's a little complex to explain, but the idea is that you have these large weight matrices that are really expensive to train. And what LoRa lets you do is essentially take that weight matrix, which is sort of how all the learned parameters in neural networks are represented, and break them into two smaller matrices, which when multiplied will have the same shape. But in terms of like the number of parameters, it's like exponentially smaller. So what I've seen from my own experience so far is that typically, like when we use like things like LoRa, you can decrease the number of trainable parameters by up to like 10,000 times. And then the amount of compute you need, like GPUs, by 3 times, which is actually a pretty significant win, all while gaining pretty much the same performance. And yeah, and so this has been sort of a new innovation. I know I dived into fine tuning, but the idea is, ultimately that in the case that you realize that prompting doesn't go very far, you can fine tune your model. You have two approaches: either update all the weights or just some of the weights. Um, Updating full weights can be very expensive and it can lead to a lot of issues. So usually people have started using these like parameter efficient methods, and LoRa is a very popular one that you can use. And all of this also already exists in Predibase, and you can use it today. Daliana, I think you might be muted.
Yeah. So I was going to ask, how should we custom LLM? When should we do prompting? When should we do fine tuning? But since we talked a lot about those concepts and structured data, I wonder if you can give us an example, maybe through Predibase or Ludwig, give us a walkthrough. How can you use the platform to do this, and what does it look like, the entire kind of training, fine tuning process?
Yeah, absolutely. Let me share my entire screen. So I can show you. Yeah, share screens. Hopefully, you guys able to see
Not
see my
yet.
screen?
Okay,
Okay.
we can see it now.
Okay. Oh,
No.
not anymore. Sorry. Yeah, that's my bad. Let's do this quickly. So yeah, essentially, I think now you
Yeah.
should be able to see it. So this is the Predibase platform, and pretty much almost everything that we've talked about today conceptually is something that we expose in the platform. So there's a bunch of large language models that these are open source large language models that you can query. These are just few that we have, but it's really easy to deploy your own sort of open source LLM to Predibase. You can make ask simple queries here. Like what is the capital of Italy, which as we learned is either short and it will get a response. But let's say you want to use your data, you have the option to select a data set for indexing. So let's say I do like hotel reviews as we discussed. It will index the data, and then you can ask questions about it and or use it for other tasks like generation or summarization. The one cool thing about Predibase is also that we support batch inference. So you can sort of make predictions across all the rows in your data set. So let's say you have a lot of like questions, but you want to generate answers for. You can just select that data set and then we'll produce all the answers in batch, which is pretty cool. I haven't seen that functionality out there a lot. You can also control some model parameters for generation, such as temperature and max new tokens, which are some pretty popular
For folks who
parameters
are not
that
familiar
a
with,
lot of people.
can you explain a little bit what is temperature? What does max new token means? How does it affect the
Yeah.
output?
Yeah, sure. So max new tokens, let's start with that one first. So max new tokens is essentially like the number of tokens you want the LLM to produce. So the way these LLMs work is they produce a token at a time, sort of iteratively, and they string together an output response. And so what this parameter just says is what is the maximum number of tokens it can produce. The LLM may produce up to this much or fewer, depending on sort of the generation itself. Temperature is a bit harder to explain, but maybe instead of explaining like what exactly it is, I can explain an intuition on how to vary this number. So the one easiest way to think about temperature is that it's a way of balancing more objective generation with more creative generation. So when your temperature is low, the model tends to be less creative in its generation. So if I was to ask like what is the capital of Italy with a temperature of 0.1, I'd probably get Rome. But as you start increasing temperature, a pretty common value is like 0.7. It sort of balances a more creative response with a more objective response. So you start seeing the LLM gets a little bit more creative in like its language, in its structure, in the way that it chooses to sort of respond to even simple questions. It's really good for more creative sort of like output tasks, like maybe like generating like product descriptions, like a natural language product description from like product specifications. You probably want to have a higher temperature. But for more objective questions, like if you're using a data set, I would probably stick to like 0.1 or lower temperatures.
Gotcha.
Mm-hmm. Cool. So the other thing I'd like to quickly show you guys is LLMs. So this is essentially like our way of doing model creation through Ludwig, our open source project. And what you can do is file uploads. I'm going to select, let's try that again. But essentially what I wanted to show you guys here is just, yeah, that makes sense. Don't disagree with that. Let's get a new model version, build a custom model, file uploads. There we go. And then, so I have, okay, not sure what's happening, but it's fine. I think I can still get through most of what I want to get through without it. Essentially, you can pick like your data set. It could be anything. Actually, this might be pretty hard to do. Okay, cool. Oh, that's what I wanted though. Apologies. Let's do. Oh wow. Okay. Well, as you know how it goes.
Do you have a model you already trained that you can just do like retrain a different version?
Yeah, actually, I do. Instruction. Okay. So yeah, this is an example of sort of a fine-tuned model that I tried to replicate sort of Stanford's Alpaca fine-tuning on the Llama model using LoRa, and you can see that essentially, I have this input sort of text, which is the instruction, and an output. I'm able to define my prompt and task as we discussed. So you can see I'm using a bit of a template. I'm giving it some context, and I'm asking for a response. And then I can specify sort of the parameter efficient fine-tuning strategy, in this case, LoRa. And LoRa has a bunch of parameters that are very easy to configure in this sort of in this way. There's also a bunch of training parameters I can configure, such as batch size, learning rate, how often I want to save the model weights, things of that nature. And I decided to fine-tune for 3 epochs. And I fine-tune on Llama. So it's very easy. I wish I could show you the model builder experience, sorry. But yeah, it's very easy to sort of go through the process of fine-tuning an LLM through Predibase. And we're able to support fairly large models like Llama 7 billion today in the platform on your data set. And so this fine-tuned for some time, and for about 2 hours or so, tuned about 3 epochs. You can see learning curves and things of that nature. Loss is decreasing. But in a similar fashion to this, the other thing I wanted to show you is that you can do batch inference and evaluate on your data set. So you can do zero-shot and few-shot evaluation with semantic retrieval. So when I say semantic retrieval, I mean like retrieval augmented generation, also in the exact same way. The difference is that you can actually configure this config to produce and you can get evaluation metrics back. So you can actually see, using few-shot learning, what was the accuracy, or what was the recall, what was the precision, which is pretty cool, because you're not able to do that through like regular query experiences, but you can do that through Predibase and Loopwig. And the last thing I'll point out is that for doing a lot of LLM stuff, I think one of the biggest challenges is getting the right compute, both in terms of CPUs, GPUs, sort of scaling those workloads based on like model size, data set size, and things of that nature. And we handle all of that through Predibase. So all you need to do is connect your data set, go to models, go to the model builder, hit train, and we'll handle everything else for you when it comes to LLMs. And yeah, it already exists in the platform.
Great. So you showed us how to basically in Predibase, you can do fine tuning. You can also do prompt engineering. So how do I decide when to use prompting? When should I fine tune?
Yeah, that's a really, really good question. Let me think about that for one moment. So I think the way okay, yeah. So essentially, I think the thing you should always do is okay. So largely the question, like this question of like prompting versus fine tuning, boils down to a couple of key things. One is, what performance are you getting with just regular prompting? Sort of the computational and financial resources you have individually or as an enterprise company, the amount of data you have, and the quality of the data itself. So these are like the 4 big factors I think that help you decide which way to go. But to sort of dive in, I think the one thing everyone should always do is prompt. The reason is that it's really, really easy to do it. And iteratively improving your prompt can usually get you 90% of the way there on most tasks that you have. So some of the advantages beyond like saying that you can get where you want to get in 90% of the cases with just prompting is that when you prompt, you get a response pretty quickly. And so the feedback loop for prompting is very quick, as opposed to fine tuning, which takes on the order of like a few hours to a few days, depending on data set size and the model you're training and how you're fine tuning it. And you need like very few resources to just prompt an LLM. Even if you're doing things like in-context learning or retrieval augmented generation, you can get a pretty fair sense of whether you actually have enough data and the quality of the data also through like prompting and retrieval augmented generation. And what I found, a lot of people, for example, want to fine tune because they want the model to match like a specific type of language or a specific style of speaking. But empirically, what I've seen is that you can actually prompt and get the model to do that as well. So prompting is pretty much like always, you must always prompt. And if you have some data, it actually like helps a lot because you can do few shot or retrieval augmented generation. But I think there's some scenarios that definitely maybe are more suggested that you might want to fine tune. I think a big one that many of us have seen with LLMs is hallucinations, which are essentially where models produce answers that look right on the surface but are factually inaccurate. And for some pretty high uh, high urgency or high value use cases where like a wrong response would have really like big consequence, such as in hospitals or things of that nature, I think that's where fine tuning is important, because you might have to teach the model when to say I don't know the answer, or when the answer is not there from your data. So I think that's a big reason to fine tune. In most cases, even prompting can do it, but I've seen that fine tuning does it more successfully more often. So that's one big reason to fine tune. I think another one is that remember that these LLMs are pre-trained on all sorts of data, and we actually have no idea what kind of data these models are fine-tuned on. And so in live production settings, what's totally possible, although rare, assuming you haven't done enough prompt engineering, it's possible that the LLMs produce like responses that are sort of like from data that's not even your data. And those are things that might be like highly undesirable. Like you can imagine, it's a very like probably like 0.1% chance of happening, but you're a company talking about, it's a chatbot about your products, and this LLM starts talking about your competitors' products. Like that's something you never want to have, right? And so that could be a reason also to fine tune, to sort of like coerce it or like teach it to stick to your data. So I'd say that's a big reason to fine tune as well. And then I think another yeah, I think those are like two big reasons I would say for fine tuning. And then generally, if you have a lot of data, I think one of the challenges with prompting is that you have to like usually evolve the prompt over time. Let's say your data is shifting or the types of questions coming in are changing, you'll have to keep updating the prompt. Whereas the idea of fine tuning might, if you're smart about it, could just be for it to learn your domain specific words and language, more so than like a specific task itself. And that means you can just fine tune once and mostly get away with it without having to constantly like iterate or update your prompt. And I think that's again like a pretty big benefit. But finally, like what I'll say is they don't have to be independent of each other. You can actually do both. So you can combine the idea of prompting in your data set as you fine tune it. And so you have all the context information provided by the prompt being passed in during fine tuning. And that's actually something I did when I was base where we're fine tuning.
I think what Arnav is going to say, I think that's what he did when he talked about the talk about the hotel rating example.
Yeah.
So for example, you can are you going to talk about the hotel rating example?
Yeah, I could. So are you thinking about like sort of like how would you iterate over that prompt? Yeah, so initially you can just ask it for a sentiment for the review, and then from there you can ask it what was the quality of that like review for the sentiment, and then that's zero shot. You can sort of expand that to here are some examples. Like for this sort of text review, this was sort of a rating that we gave for sentiment. Give it a few examples, and then you have retrieval augmented generation or few shot learning. And then what you can do for fine tuning is take the same prompt template, explain some criteria for each rating level, actually give it a few examples, and then say, what would you rate this? And then give it like the output data, and then fine tune it that way as well. And so basically you sort of like iterate it through. I think the biggest thing in this customization journey is the amount of data you have and the quality of data you have, as well as do you have the means to fine tune, because it's expensive and honestly like quite difficult to fine tune successfully.
Okay, I think we have gone through 10 of the questions. Sorry about the disconnection issues we have. And I think before we wrap up, okay, you're back. I was just gonna say, can you give us maybe a 1-minute summary of the most important takeaways from this talk?
Yeah, so like one with summary of like takeaways from this talk. I think one, large language models have a lot of potential. There's a lot of things we know about it today, but there's a lot of things we don't, and we're all trying to learn and figure it out together. But it's a very exciting space because it unlocks a very large range of possibilities for what we can do and the kind of products we can build and the tools we can build. So that's one. Two, the best way to, people always think about, when they think about large language models, they think ChatGPT and question answering. And that's one of many use cases, but really, like, we're not limited to that. You can do almost anything imaginable with large language models on a wide range of tasks. And that's something you should definitely be doing. You don't really want like general models. You want task specific models and using them for your specific tasks. Third is that depending on the amount of data you have, you can customize your model in many different ways, all the way from having no data where you do zero-shot learning to some data where you do few-shot learning and retrieval augmented generation to fine-tuning where you have a lot of data that's of high quality. And lastly, all of this, it's a pretty iterative journey. You sort of have to try some of these things, but the faster, like the faster you can, like the better your iteration cycle is, the more value you can extract. And so you want to make sure you set yourself up for success in a way that's really easy, or use a tool or platform that makes it really easy to do that, so that you can solve the use case that you have. So I think those are some high level takeaways of all the things we chatted about.
Great. Thank you so much, Arnav, and thanks for everybody for being here with us and asking great questions. If you have more questions, we also have our open source Ludwig community. We have a Slack group. You can ask questions there and follow Predibase LinkedIn page. We're going to do more webinars and ML real talks around large language models. And if you have signed up, you'll get a recording for this one. All right. Thank you, everyone.
Thanks.